What's up, guys? Today we're going to be talking about Euler's method of approximation. So today, to help us understand this concept, we're going to be using this differential equation here with these constraints. So what is Euler's method of approximation? So in Euler's method of approximation, we're essentially going to be using lines to approximate the value at a certain point. So if we take steps of 0.5 here and approximate what f of x is at 2, so essentially what we're doing here is we're drawing secant lines at certain steps to stay close to the graph and approximate what the value of f of x would be at a certain point. And so we can apply this to this problem here, as we can take the slope of the graph and form a line at that point and then calculate what the next step value would be. So let's apply this. So we're going to start off with drawing a table, and we've been given that y of 3 equals 1. So if we're starting at 3 and we want to approximate what y of 5 is, and we're using steps of 0.5, we're going to need 4 steps in total. And I've plugged in our first values here, and what we're going to start with is we're going to start with finding y prime. To find y prime, we're going to use a differential equation and plug these values into here. So with this, we can construct a line to find what the next step value would be. So here we have the formula of the line for the second step. When we write x minus whatever the x value is, in Euler's method problems, this is always going to be the value of the steps. So basically, every line formula we make for each step, this term is going to be equal to 0.5. So we can simplify this. (0.5) is what you get when you plug in the next step of this process, which is going to be 3.5. So 3.5 minus 3 would just become 0.5. And with this, you can calculate the next y value. So now that we have the x and y for the second step, we can get the slope for the line of the second step. So again, we have all three of these components which can help us form the second step line formula. And once again, I just put in the 0.5 again because, as I explained before, the next step minus this is always going to be 0.5 because we're incrementing by 0.5. Now, if you carry this line formula process out 2 more times, you'll arrive at x equals 5, and you'll be able to calculate what y is. You'll be able to approximate what y is at x equals 5. So now that I've carried this out all the way, I've arrived at x equals 5, and through the fourth step, I was able to model our final line and get the approximation for y of 5, which was 8.61. So with this, we can conclude through the Euler's method of approximation that y of 5 is approximately equal to 8.61. So there's a simple rundown on how to use the Euler's method, and let us know what you'd like to see next. Thanks for watching.